Hello, and welcome to the continuation of these video lectures. We will now be looking at section 2.3. As soon as you're finished with this video lecture and feel you're ready to do the homework, these are the assigned problems for section 2.3, and they can be found at the end of chapter 2. Alright, I noticed in the last video that some of the videos occasionally turn blank. I don't know what's causing that, and I will try to kind of pause for a second until the image comes back, but hopefully that won't be too much of a problem. I guess my equipment isn't that great. Okay, now we're going to begin section 2.3. These are angles in standard position. Okay, standard position is what we need to first understand. An angle in standard position has its initial side, the starting side that you're measuring from, lying from the origin out the positive direction on the x-axis. So that is where the initial side will always be in an angle in standard position. And then the measure of the angle will either be positive if you're going around this direction, counterclockwise, or negative if you're going around in a clockwise direction. Okay, that's from chapter 1. When is the angle said to be in a first quadrant angle? Well, if the terminal side, terminal is the ending side, remember, of the angle, and that was in the beginning of the chapter 1. The terminal side is in quadrant 1. We call it a first quadrant angle. And we want to define co-terminal angles. Co together, or the same, or both. These have the same terminal side. So this angle here, let's say that's, I don't know, what do we want to say? Oop, the video went out there. So let's say that's 60 degrees. That'll be easy. It doesn't look like it's 60, but it'll make it easy. And that's a positive angle, 60 degrees. It is coterminal with an angle that goes around here and lands at the same place, and that would be an angle of negative 300 degrees, would be coterminal. They share the same terminal side, the 60 degree and the negative 300 degree. Or you could take 60 plus 360 to get another coterminal angle. We'll do several examples like that in a minute. So here we go with some angles over here to show you how these are measured. Okay. What is a quadrant angle? A quadrant angle is an angle in standard position that has a terminal side along an axis. Okay, so a quadrant angle would be one that started here and landed on either that axis, or it could land over here, or it could land down here. It lands on one of the axes, the terminal side. So it exactly matches up with one of the quadrants or more than one of the quadrants. So a 90-degree angle would work, a 180, 270, 360, and so forth. Okay. Let's go ahead with this first example, continuing through this section. This is example number 4. When the hands of an analog clock display 3:05, and I know people don't really read these very much anymore, 12 o'clock, 3 o'clock, 1, 2. So at 3 o'clock, the hour hand is pointing out here to 3 o'clock, and the minute hand is pointing to 05, 5 minutes after the hour, right there. And so we see our angle there between them. Keep in mind that if you measure around the clock, we have 12 of these. So we have 360 degrees. And we're talking about 12 partitions of this circle in the 12 hours. And we're using 2 hours here. 1, 2. So we have 2/12 of the circle. And it's 360 degrees. So take 360 times 2/12 to find out how many degrees this angle is right here. We'll call that theta. And the angle would be 60 degrees. Okay, so this angle theta is 60 degrees. I'm trying to wiggle the mouse because I think maybe that keeps it from blacking out on us. So angle theta is 60 degrees. Now what did it ask us? Let's see. Approximate the angle formed by the hands. We found it exactly, I say. At what other time are the two hands in this position and form approximately the same angle? Well, wouldn't that be when... Oops, kind of got carried away there. Let's try again. 12, 3, 1, 2. What if the hour hand were pointing to 1 and the minute hand were pointing to 3? They would be exactly in the same position with the same angle, wouldn't they? All right. So, what are the other times? What other time are the two hands in this position and form approximately the same angle? So that would be at 1:15, right? 1:15. So that's the second question. And then we're supposed to give an example of a coterminal angle to do this. So we'll just give a coterminal angle. So we'll take 60 degrees, and to get a coterminal we have to go around the circle again one way or the other. So you could add 360 or subtract 360. I'm adding it. So 420 degrees is coterminal with the initial angle. Okay. I think too this is kind of weird, but I did take the wording from the book, I guess. Okay, let's pause the video now and try practice problem number 4A. Notice there, actually go ahead and do practice 4A, B, and the last B. I guess I should have called that C, perhaps, yes? Okay. All right, let's go ahead with 4A. If the point -3, -1 lies on the terminal side of an angle, so let me think about that. -3, -1, somewhere over here, and we have a terminal angle, so it starts over here, and it ends with a line that goes through that point, right? The angle goes like that, around that. That's not my most beautiful drawing. This is a quadrant blank angle. So what quadrant does that angle land in? It's a quadrant 3 angle. Back to the quadrants that we talked about in the last section. All right. And the first 4B here. Give two positive and two negative angles that are coterminal with an angle of measurement 90. Okay, so 90 is coterminal with, we could add 360 to that, and we'll get 450 degrees, so that would be another positive angle. And to that we could add another 360 degrees to get the next one, and that would give me 810 degrees. So two positive angles would be 450 and 810. It also wanted some negative angles that had the same coterminal, so I'll take 90 degrees and I'll subtract 360, and that's going to give me an angle of -270 degrees. And then we can subtract another 360, so there's one negative angle that's coterminal with a 90-degree angle. Subtract 360 again from that, and you'll get the next one, which would be -630 degrees. All right. And finally, this should be 4C. Give one positive angle and one negative angle that are coterminal with this. So the trick on this is it's in radians, right? And we have to keep it in radians. And that means instead of adding degrees to radians, we must add like terms, which would be more radians. So I'm going to begin by taking 3/4 pi and adding 2 pi to it. Well, I know that 3, that's my pi over 4. 2 pi is the same as 8/4. 8/4 pi. I need it to be fourths, so 2 pi is the same as 8/4 pi. So I converted that to an equivalent fraction. So I'm adding 8 pi fourths to 3 pi fourths, which gives me 11 pi fourths is a positive angle that's coterminal with 3 pi fourths. Now I'm going to do it for the negative angle. I'm going to take 3 pi fourths, and I'm going to subtract 2 pi, which means 3 pi fourths minus 8 pi fourths. Okay, and that should give me -5 fourths or negative 5 pi fourths. So this is a negative angle that is coterminal, that lands at the same place as 3/5 pi fourths would. Okay? You're now ready to do your homework from 2.3, and when you've completed that, we have one more video lecture.